there! Welcome to...
Hold on! It's my turn! World Wellness Green Store! Let's go explore the green wellness together!
Hey everyone, and welcome back to the channel. Today, we're diving deep into one of the most crucial parts of any aquaponic system, the fish. You see, it's not just about growing plants. It's about creating a thriving ecosystem. And understanding the biology of your fish is the key to unlocking its full potential. So grab your notebooks, because we're about to explore the fascinating world of aquaponics fish biology. First things first, let's talk about the absolute foundation, the nitrogen cycle. Now, I know we mention this a lot, but it's that important. Your fish aren't just swimming around looking pretty, they're the engine of your system. They eat food, and just like any living creature, they produce waste. This waste comes out primarily as ammonia, which is toxic to both the fish and the plants if it builds up. This is where the magic of biology kicks in. A group of beneficial bacteria, called nitrifying bacteria, colonize your grow media and water. The first group, nitrosomonas, converts that toxic ammonia into nitrite. Nitrite is still harmful to your fish, so a second group of bacteria, Nitrobacter, steps in. They take that nitrite and convert it into nitrate, and nitrate is the gold mine. It's a fantastic, readily available nutrient that your plants absolutely love to soak up. So, your fish produce waste, bacteria convert it, and plants consume the final product. This cleans the water, making it safe for the fish to live in. It's a perfect, self-sustaining loop. Now, which fish should you choose? This is a huge question, and the answer depends on your goals, your climate, and your system size. Let's break down some popular choices. Tilapia are probably the most common aquaponics fish, and for good reason. They are incredibly hardy and can tolerate a wide range of water conditions, including lower oxygen levels and temperature fluctuations. This makes them very forgiving for beginners. They also grow super fast, and you can harvest them for food in as little as 6 to 9 months. They're omnivores, so they'll eat a variety of foods, which keeps feeding simple. They do breed very easily though, so you might need a plan to manage their population if you have both males and females. Next up, we have trout, specifically rainbow trout. These are a fantastic choice for cooler climates. Unlike tilapia, trout thrive in colder water, typically between 50 and 68 degrees Fahrenheit. They require high quality, well-oxygenated water, so they're a bit more demanding than tilapia. If you can provide the right environment, you'll be rewarded with a delicious, fast-growing fish. They are carnivores, so they need a high-protein diet, which is something to factor into your costs. What if you're not interested in eating your fish? Then you might want to consider ornamental fish like goldfish or koi. Goldfish are extremely resilient, similar to tilapia. They produce a good amount of waste to fuel your plants and can handle a variety of conditions. They're a great, low-maintenance choice for smaller, decorative systems. Koi are like the majestic cousins of goldfish. They get much larger, live for a very long time, and are absolutely beautiful. They produce a ton of waste, making them powerhouses for larger systems designed to grow nutrient-hungry plants. Keep in mind, because they get so big, they need a much larger tank or a pond to thrive. Another great option, especially for warmer climates, is the bluegill. They are part of the sunfish family and are known for being hardy and having a great taste. They are relatively easy to care for and can tolerate a range of water parameters. They grow a bit slower than tilapia, but many people prefer their flavor. They're also known to be quite interactive, which adds a fun element to your system. Now, let's talk about what keeps these fish healthy and happy, which in turn keeps your system productive. Water quality is paramount. We've talked about the nitrogen cycle, but you also need to monitor pH. Most aquaponic systems run best with a pH between 6.0 and 7.0. This is a happy medium that keeps the fish, the plants, and the beneficial bacteria all content. A pH that is too high or too low can stress your fish and make nutrients unavailable to your plants. Oxygen is another non-negotiable. Fish breathe dissolved oxygen from the water. You need to ensure your water is constantly aerated. This is usually done with an air pump and air stones, or by designing your systems so that water splashes and tumbles as it circulates, which naturally incorporates oxygen. If you see your fish gasping at the surface, it's a major red flag that your oxygen levels are dangerously low. Temperature is also critical and, as we've seen, often dictates your fish choice. Every fish species has an ideal temperature range. Operating outside this range will cause stress, reduce their appetite, stunt their growth, and make them more susceptible to disease. A simple aquarium heater or chiller can help you maintain the perfect temperature for your chosen species. Feeding is another huge piece of the puzzle. The food you put in is essentially the main input of nutrients for your entire system. You need to feed your fish a high-quality, complete diet. The amount you feed is also important. A good rule of thumb is to only give them what they can completely consume in about 5 minutes. Overfeeding is a common mistake. Uneaten food will sink to the bottom and rot, which fouls the water, consumes oxygen, and can lead to harmful ammonia spikes. It's a waste of money and a danger to your fish. Finally, let's touch on fish health and disease. The best way to deal with disease is to prevent it in the first place. A well-maintained system with stable water parameters, proper oxygenation, and a low-stress environment is your best defense. When you get new fish, it is a great idea to quarantine them in a separate tank for a couple of weeks to make sure they are bringing any unwanted diseases into your main system. If you do spot a problem, like white spots, frayed fins, or lethargic behavior, it's important to identify the issue and act quickly. However, be very careful with treatments. Many common fish medications are harmful to plants and your beneficial bacteria, so you might need to treat sick fish in a separate hospital tank. Always choose treatments that are aquaponic safe if you must treat the main system. So there you have it, a crash course in the biology of aquaponics fish. They are so much more than just a source of fertilizer. They are the living, breathing heart of your ecosystem. By understanding their needs from the nitrogen cycle and water quality to the right food and environment, you can ensure they thrive. And when your fish thrive, your bacteria thrive, your plants thrive, and your entire aquaponics journey becomes more successful and rewarding. In aquaponic systems, fish waste is not simply a byproduct that must be removed. Instead, it becomes the primary nutrient source that supports plant growth. Understanding how fish produce waste and how that waste enters the nutrient cycle helps growers manage feeding practices, fish density, and plant production more effectively. According to research from public aquaculture institutions and agricultural universities, the connection between fish metabolism and nutrient availability is one of the central principles that allows aquaponic systems to function. Fish waste originates primarily from two biological processes, digestion and metabolism. When fish consume feed, the digestive system breaks down proteins, fats, and carbohydrates into smaller molecules that can be absorbed into the bloodstream. These nutrients provide energy for metabolism and support tissue growth. However, not all components of the feed are fully absorbed. Some materials pass through the digestive tract and are released as solid waste. Solid waste particles consist of undigested feed fragments, organic matter, and microbial material from the digestive system. These particles are heavier than water and tend to settle or remain suspended in the water column depending on system flow. In aquaponic systems, mechanical filtration is often used to remove large solid particles before they reach plant roots. Removing excess solids prevents clogging in pipes and protects root zones from excessive organic buildup. In addition to solid waste, fish also release dissolved waste directly into the surrounding water. The most important dissolved waste compound is ammonia. Ammonia forms when fish metabolize nitrogen-containing amino acids from dietary proteins. This ammonia is released primarily through the gills as fish exchange gases with the surrounding water. Public aquaculture research programs explain that this process is a normal physiological function of fish metabolism. Once ammonia enters the water, it becomes part of the nitrogen cycle within the aquaponic system. Ammonia is toxic to fish at elevated concentrations, so it must be converted into safer compounds. Beneficial nitrifying bacteria convert ammonia first into nitrite and then into nitrate. Nitrate is far less harmful to fish and becomes an important nutrient for plant growth. Plants absorb nitrate through their root systems as part of their normal nitrogen uptake process. Nitrogen is essential for plant growth because it forms part of amino acids, proteins, and chlorophyll. When plants absorb nitrate from the water, they remove nutrients that originated from fish metabolism. This process helps maintain water quality for the fish while simultaneously fertilizing the plants. The amount of nutrients available for plant growth depends largely on fish feeding rates. Fish feed contains proteins, minerals, and other nutrients that eventually become available to plants after digestion and bacterial conversion. Public agricultural research institutions explain that the quantity of fish feed entering the system often determines the total nutrient input in aquaponics. Because fish feed drives nutrient availability, growers must balance fish population size with plant production. If fish density is too low relative to the number of plants, nutrient production may not be sufficient to support plant growth. Plants may show signs of nutrient deficiency because not enough nitrogen is entering the system through fish metabolism. If fish density or feeding rate is too high, however, ammonia may accumulate faster than bacteria can convert it. Excess ammonia can harm fish and disrupt the balance of the aquaponic ecosystem. Maintaining appropriate stocking density and feeding schedules ensures that waste production remains within the processing capacity of the biological filtration system. Fish feeding behavior also influences waste production. Most aquaculture species used in aquaponics, such as tilapia or trout, are fed formulated pellets designed to provide balanced nutrition. These feeds are designed to maximize growth while minimizing excess waste. Public aquaculture research programs emphasize that overfeeding should be avoided because uneaten feed can decompose in the water and contribute to poor water quality. Uneaten feed not only increases organic waste, but also increases oxygen demand as microorganisms begin breaking down the material. Decomposition processes consume dissolved oxygen, which may reduce oxygen availability for fish and nitrifying bacteria. Careful feeding practices therefore help maintain both water quality and biological filtration efficiency. Fish size and growth stage also influence waste production. Younger fish typically consume smaller amounts of feed and produce less waste than mature fish. As fish grow larger and their metabolic rates increase, waste production rises accordingly. Aquaponic system management often adjusts feeding schedules and plant density as fish populations grow. Temperature also affects fish metabolism, and therefore waste production. Warmer water within the species' optimal temperature range generally increases metabolic activity. Fish may consume more feed and produce more waste at higher temperatures. However, excessively warm water can reduce oxygen availability and stress fish populations, so the temperature must be managed carefully. Solid waste particles may also contribute nutrients after microbial decomposition. Organic matter contained in fish feces and uneaten feed can break down gradually through microbial activity, releasing additional nutrients into the water. Mechanical filtration systems help regulate this process by removing excess solids before they accumulate excessively. The relationship between fish feed input and plant nutrient availability creates a direct link between aquaculture and horticulture within aquaponic systems. Each gram of fish feed introduced into the system eventually contributes nutrients that support plant growth after biological conversion processes occur. Because of this relationship, many aquaponic growers calculate feeding rates based on the nutrient requirements of the plants they intend to grow. Public agricultural extension programs often provide guidelines that estimate how much fish feed is required to support certain plant production levels. Understanding how fish waste becomes plant nutrition allows growers to manage aquaponic systems more effectively. Fish feed enters the system as energy and nutrients for fish. Metabolism produces waste compounds. Bacteria convert those compounds into plant nutrients, and plants absorb those nutrients while improving water quality. This continuous movement of nutrients from fish to plants forms the foundation of aquaponic productivity. Maintaining healthy fish populations and balanced feeding practices ensures that the nutrient supply supporting plant growth remains stable. Recognizing how fish waste contributes to nutrient availability also highlights the importance of monitoring fish health and environmental conditions, which will be examined in the next section. Maintaining fish health is one of the most important responsibilities in aquaponic system management, because fish not only represent a food product but also drive the nutrient cycle that supports plant growth. When fish experience stress or health problems, their metabolism, feeding behavior, and waste production can change significantly. These changes can disrupt the balance of the aquaponic ecosystem. According to research from public aquaculture institutions and veterinary aquatic health programs, Understanding the environmental factors that cause fish stress and recognizing early health indicators allows growers to maintain stable and productive systems. Fish stress occurs when environmental conditions exceed the biological tolerance of the species being raised. Fish are highly sensitive to changes in water chemistry, oxygen availability, temperature, and population density. Because fish live entirely within the water environment, any change in water quality immediately affects their physiology. Maintaining stable water conditions is therefore essential for protecting fish health. One of the most common stress factors in aquaculture systems is insufficient dissolved oxygen. Fish require oxygen to support respiration and metabolism. When oxygen levels drop below species-specific requirements, fish may begin to display behavioral signs of stress. These behaviors may include increased surface swimming, rapid gill movement, or reduced activity. Public aquaculture research institutions emphasize that maintaining adequate aeration and water circulation helps prevent oxygen-related stress. Temperature fluctuations can also influence fish health. Fish are ectothermic organisms, meaning their body temperature and metabolic rate are influenced by the surrounding water temperature. When water temperatures fall outside the preferred range for a species, metabolic processes may become inefficient. Extremely low temperatures can slow digestion and reduce immune function, while excessively high temperatures may increase oxygen demand and physiological stress. Water chemistry parameters such as ammonia, nitrite, and nitrate concentrations also affect fish health. Elevated ammonia levels can irritate gill tissues and reduce oxygen uptake. Nitrite exposure can interfere with oxygen transport in the bloodstream. Although nitrate is much less toxic than ammonia or nitrite, excessively high nitrate concentrations may still affect long-term fish health. Public aquaculture monitoring guidelines therefore recommend routine water testing to maintain safe ranges for these compounds. pH levels influence both fish physiology and bacterial filtration processes. Sudden shifts in pH may stress fish because they affect the balance of ions within the fish's body fluids. Stable pH conditions support both fish metabolism and the bacterial populations responsible for nitrification. Monitoring and gradual adjustment of pH helps maintain overall system stability. Stocking density is another factor that influences fish stress. When too many fish are placed in a limited space, competition for oxygen and food increases. High population density may also increase the accumulation of metabolic waste products. Public aquaculture research programs recommend maintaining appropriate stocking densities based on tank volume, species characteristics, and system filtration capacity. Feeding practices can also influence fish health. Underfeeding may lead to slow growth and weakened immune systems, while overfeeding can degrade water quality and increase ammonia levels. Balanced feeding schedules provide fish with sufficient nutrition, while minimizing uneaten feed that could decompose in the system. Observation of fish behavior provides valuable information about health conditions. Healthy fish typically swim actively, maintain balanced posture, and respond quickly to feeding. Fish that appear lethargic, isolate themselves from the group, or swim erratically may be experiencing environmental stress or illness. Early behavioral changes often appear before visible physical symptoms develop. Physical health indicators can also help growers identify potential problems. Healthy fish generally display clear eyes, intact fins, and smooth scales. Changes such as discoloration, fin damage, abnormal swelling, or lesions may indicate disease or environmental stress. Public aquatic veterinary programs recommend careful observation of these physical indicators as part of routine system management. Gill condition provides another important health indicator. Because gills are responsible for gas exchange, they are sensitive to water quality problems. Healthy gills typically appear bright red due to rich blood supply. Pale or damaged gills may indicate oxygen deficiency or exposure to harmful compounds such as ammonia. The immune systems of fish function most effectively when environmental conditions remain stable. Stress weakens immune responses and increases vulnerability to pathogens. Maintaining stable water parameters, appropriate feeding, and adequate oxygen helps support natural disease resistance. Preventive management strategies are widely recommended in aquaculture and aquaponic systems. Instead of reacting to disease outbreaks after they occur, growers focus on maintaining environmental conditions that support healthy fish populations. Routine monitoring of water chemistry, careful feeding practices, and consistent observation of fish behavior all contribute to preventive health management. Quarantine practices may also be used when introducing new fish into an established aquaponic system. Isolating new fish temporarily allows growers to observe them for signs of disease before adding them to the main population. This precaution helps prevent the introduction of pathogens that could affect the entire system. Fish health directly influences plant productivity in aquaponics because fish metabolism determines nutrient availability. Healthy fish consume feed efficiently, grow steadily, and produce consistent waste that supports the nutrient cycle. When fish become stressed or ill, feeding behavior often changes, which can reduce nutrient input and disrupt plant growth. Understanding stress factors and health indicators therefore helps growers maintain both animal welfare and system productivity. By monitoring environmental conditions and observing fish behavior regularly, aquaponic operators can identify potential problems early and maintain balanced ecosystems that support both fish and plant production. Thanks for watching World Wellness Sustainable Farming.
Thanks for watching. Hope you liked it.